Florida waterfront living looks perfectly serene until a tropical storm rolls in. Suddenly, that gentle sea breeze turns into a violent, destructive force, putting extreme physical stress on every structure you own. A screen cage functions as a structural extension of the house itself. Because of the sheer pressure of coastal winds, Florida's building codes require patio hardware to meet specific engineering standards designed to prevent structural collapse. This waterfront microclimate presents a continuous combination of threats. Notice the aerosolized salt air. Sea breezes carry microscopic salt particles miles inland, where they penetrate metal surfaces and act as a powerful catalyst for rapid oxidation. Unseen environmental forces degrade these structures daily. Ignoring that wear creates a major structural liability the moment a hurricane force gust hits the property. This diagram shows the invisible war on outdoor living spaces. Heavy downpours force moisture deep inside standard connections, creating microenvironments for oxidation. Down on the right, relentless sunlight bakes the fiberglass mesh, destroying protective coatings and causing fibers to thin and lose elasticity. When hidden joint decay combines with brittle, sun-baked mesh, the structure loses its ability to handle sudden pressure. A single severe gust can cause a collapse, often resulting in damages that standard insurance policies exclude from coverage. To understand how to prevent this, we must look closely at how these enclosures are built. An engineering audit of a typical cage almost always reveals the exact same initial failure point: the fasteners. This highlights the earliest warning sign of structural compromise. Most installations use cheap, ceramic-coated steel screws. In a salty environment, a galvanic reaction occurs between the steel screw and the aluminum frame. The internal threads dissolve, trapping moisture and bleeding orange rust down the framing. The professional remedy for this is straightforward. Halting this bimetal corrosion requires 100% true stainless steel hardware, which resists the chemical reactions that tear standard self-tapping screws apart over time. Down at the foundation, look at the structural connections where the cage meets the concrete. Wind continuously vibrates the entire enclosure. Combined with moisture intrusion, this vibration systematically loosens the critical base anchors that hold down standard 18-foot spans. To survive massive uplift forces, the Florida Building Code dictates strict anchoring standards. As this blueprint extract shows, the aluminum post must be secured to a continuous reinforced concrete footing, a minimum of 8 by 8 inches, using heavy-duty chemical anchors. The structural geometry of the cage depends on those reinforced anchors and stainless steel fasteners holding the frame firmly together. Once the frame starts to flex at the joints, the entire enclosure is compromised. We also have to account for wind pressure. It is a common misconception that screen mesh lets all the airflow through it. In reality, modern tight weave screens catch a significant amount of wind, turning the enclosure into a giant sail. This diagram illustrates how the building code calculates pressure. If using dense screens or solid panels, engineers must design the frame to withstand 30 pounds per square foot of wind pressure. Highly open screens still require engineering for a 10-pound per square foot load. Reviewing the local permitting guidelines, there is a specific mandate for anything retractable. Removable panels must be labeled for removal at 75-mile-per-hour winds. Homeowners are legally required to retract these screens before a major storm hits, or they risk personal liability. Automation introduces its own set of vulnerabilities. In a coastal setting, salty air invades retractable housings. If the bottom guide tracks aren't cleared regularly, sand and salt crystal buildup will derail even heavy-duty tracks and short out electrical sensors. As detailed in this hardware breakdown, reliable coastal jobs require specific electrical upgrades. Installers prefer 24-volt DC motors for superior safety in wet environments, using marine-grade, damp and wet-rated motors with sealed casings and UV-resistant cabling to block out salt spray. Failing to respect wind load mathematics and marine-grade electrical standards often leads to torn mesh, binding tracks, and system failure during severe weather events. Even if your pool cage is engineered perfectly to code, surviving the waterfront microclimate requires proactive maintenance. Regular care is the only way to maximize the lifespan of these materials. This coastal audit blueprint details a reliable maintenance routine. Most important is the monthly rinse with fresh water to dissolve salt buildup. Annually, audit fasteners for orange streaks. Keep bottom tracks vacuumed clear of sand, and exercise motorized screens bi-weekly to ensure they remain operational. Sticking to this brief routine lets you spot early warning signs, like a single rusting anchor screw, before the problem spreads, preventing expensive structural rebuilds. If you are building new or replacing an old cage, look closely at the engineering. This table shows exactly how the cheap industry standard falls short. Flimsy aluminum profiles and basic screws do not meet the footings and thicknesses required by modern building codes. Screen Factory Florida provides a solution that goes beyond basic compliance. They utilize heavy-duty 0.055-inch aluminum members paired with true stainless steel hardware. Furthermore, their team handles all complex municipal permitting and engineering sign-offs, ensuring every build earns strict code compliance certifications. Navigating strict coastal building codes and wind load math requires professional expertise. Protect your home and your insurance policy by contacting Screen Factory Florida at 239-544-5464 for a free estimate on a fully compliant, marine-grade outdoor living space.